We have been thus far using this account object for our examples. So I was thinking, why not create something which is more concrete and more usable, such as a stack. So what we are going to create here is a stack which contains its standard operations, which are like pushing an element in a stack, popping an element, peeking for an element which is the topmost element present in the stack, and also whether the stack is empty or is it full. So let us quickly create this. So the idea behind creating this is, in our future examples, we will be using this stack in various ways to kind of explain subtle things in Java that needs explanation. We have created here a custom stack of integer elements, and let's see how we have defined our stack. So we have an integer array called elements, and the stack top is being maintained in this variable. We have a constructor to instantiate the stack for us. Initially, we have to pass the capacity, and with that capacity, our elements array will be initialized, and the stack top will also be initialized to -1, which means that there are no elements in the stack currently. Moving on, we have few standard operations which are basically instance methods such as push, pop, peek, is empty, and is full. Let us quickly see what each one of these does. So the push method actually inserts new elements into the stack, and the new element will be inserted after incrementing the current stack top and then inserting the element at that particular index. So that you can see here, the stack top is first incremented, and then at the new location the new element is getting inserted. Pop actually removes the last inserted element in the stack, which is being pointed by the stack top parameter or the stack top index. So here we see that whatever is at the stack top, we are reading it and we are returning it back to the caller so that we know which element got deleted, and after that we are decrementing the stack top. The peek method actually tells us what is the current element at the stack top position. What is the topmost element in the stack currently. So what it does is it just fetches the element which is there in this array in the stack top location. Is empty is a boolean value which actually shows whether the stack is empty currently, and how it does that is it just uses the index, and if it is less than 0, that means there are no elements. If the stack top is 0, that means at the array 0 location there is at least one element, so that means the stack is not yet empty. So that is why we have to compare stack top if it is less than 0. And just the opposite of this is full, which will find out whether the stack is currently full or not. So initially you see that we have instantiated the stack with a particular capacity, right? So if we are trying to insert elements which is beyond this capacity, then this is full should return true. And how we are going to do that is we have to compare the stack top, and we'll see if the length of the elements array -1 is the value of this stack top. So let's say the elements dot length is currently 5. That means the maximum possible elements which is inserted, which can be inserted into the array is 5. So 5 minus 1 is 4. So in an array, since it is a 0 indexed, so from 0 to 4 means there are 5 elements. So if this condition becomes true, that means the stack top is now currently pointing to the last location in that element array, which means that it is currently full.